And the first thing I'm going to do is I'm going to start off with an AP question. I think this was, I want to say that this was last year's, okay? Every year, there's a problem like this, okay? Oh boy, did I not, what happened to all the parts to this problem? No. All right. Oh, darn it. Oh man, how come I, shoot. 1 second here. I'm going to see if I can. Oh, okay. So what I'd like you to do is do part 1, and then I will try to get the part B and C for you guys. Maybe we can just read it off of. Oh, yep. Okay, we can just read it off. All right. So this isn't going to work as like I wanted it to. So we'll roll with the punches. Okay. So every year there's a problem like this. Okay. So this one, it says, let f be a continuous function defined on the closed interval between -4 and 6. The graph of f consists of 4 line segments, is shown above. Let g be the function defined by g of x equals the integral from 0 to x f of t. Okay. On what open intervals is the graph of g concave up? Okay. So please tell me, what intervals is g concave up? Okay. What would you say for an answer there? And I'm gonna try to bring up that problem so I can put the other questions up for you guys, so you can see exactly what they'll be asking you for. And this was, I thought this was a really good one last year. You know, but every year it will always be something very similar to this. They always have the same types of problems. I'm just trying to find that problem here. Okay, here, I got it. All right. Whew, that second part is pretty tough. Okay, so let's see what you guys came up for. -4 to 2 and 2 to 6. Okay, so when you have a derivative graph, whatever's above the x-axis, the function is increasing. So if they ask me, where is this function increasing? Oops, I don't want to write that thick. So if they ask me where the function was increasing, I would say between -4 and 1. That's where it's increasing. And where is it decreasing? Well, every place where the derivative graph is below the x-axis. So between 1 and 6, it would be decreasing. So these are things that you have to be able to look at. But that's not the question it asked. It asked, where's it concave? Well, concavity is the second derivative. So if this is the first derivative, the next derivative would just be slope. So concave up means the slope has to be positive. So where's the slope positive? Between -4 and -2, it would be concave up. Between 2 and 6, it would be concave up. So anytime they ask you, where is it increasing or decreasing? Easy question. If they ever ask you, where is it concave up or concave down? That should also be an easy question. Okay. Part B. No, I don't think I can. All right, I'm gonna have to write this down. Ooh, good question. All right. So I'm gonna write this for you guys. Okay. This is going to be a lot tougher. Okay. So part B. Let give x equal dx times f of x find p prime. That is a heck of a problem. It's an awesome problem. It puts a lot of things together, and that's what all of these AP questions do. They put a lot of things together. Okay, so what I want you guys to do is I want you to spend a couple minutes and then find, let p of x equal g of x times f of x, find p prime of 3. Okay, I'm going to let you work a little bit and see what you get. Oh, part C is awesome also. Okay, first question. What is your first step? What is the first step that you're taking here? And that's so one thing about the free response questions. You have to look at a problem and you have to start thinking about, okay, what do I have to do here? The product rule. That's exactly right. You have to take the derivative. It's asking you to find p prime of 3. And they're telling you that the p function, is this. So in order to find the derivative of p, I have to take the derivative of this. Well, that's the product rule. I have two functions. So if p of x is equal to g of x times f of x, I'm going to take the derivative of this. Well, how do you take the derivative? U prime, v prime. U is equal to g of x. U prime is equal to g prime of x. F of x is just f of x, and then the derivative of that. Inside plus outside. So the derivative of p of x is going to be g prime of x times f of x. Ooh, I'm going to have to write really small. Plus g of x, f prime of x. Now, they want me to find it at 3, right? So I'm going to put 3 in here. So this is going to be g prime of 3 times f of 3 plus g of 3, f prime of 3. All right, whoa, all right. And I'm supposed to figure all that out just with all this information? Okay, so g prime of 3, what is that going to equal? So when you think about it, isn't g prime of 3, because they told me how to find g of x, right? So g prime of 3, isn't that the value at 3 here? Because this is the g of x, so this should be -3. So I'm going to go, so this is -3. What does f of 3 equal? Okay, and those are things that you have to be able to look at. And it's like, okay, so this is the f function. So f of 3, this is the f function. So f of 3 is -3 plus g of 3. Well, g of 3 is the only hard part to get here because f prime of 3, well, this is the f graph. F prime would just be the slope right here. Isn't that just -1? No, I'm sorry, that's +1. So the slope, so that's +1. So the only thing I really have to be able to do is find g of 3. Well, g of 3 is equal to, they gave me a way to figure it out. If I put 3 in here for x, so that's going to be the integral from 0 to 3. Well, what does this mean? It means the area underneath the curve from 0 to 3. Well, that's positive. and 3 is over here, isn't it? And this is negative. So if you can find the area of this, and I already did that, it came out to be what? I think it's negative 3.5. Because I just added this area right here is exactly the same as this piece right here. So the only thing that was left was this piece right here, which is negative 3.5 because it's underneath there. And if I put all this together, I think I ended up with 5.5. But you have to be able to look at a problem like this and start working it out. Okay, now part C, so I'm going to erase this. So part C, this is what it asks. This is another really awesome problem. Kind of gets into what we're going to do today a little bit. It says find the limit as x approaches 2 of this function, g of x over x squared minus 2x. So it says find the limit as x approaches 2 of g of x over x squared minus 2x, and wants a limit. Okay, so I'm just going to give you a couple minutes just to sit and think about it and see what you would do. All right. What is your first step when you have a problem like this? Okay. What would be your first step? We're trying to find a limit. And this week, we're going to review limits, evaluate a 2. Right. So if I put 2 in here, so I want to find the limit as x approaches 2 of g of 2 over 2 squared minus 2 times 2. Well, what is g of 2? G of 2, I have to use this function again. So g of 2 is equal to the integral from 0 to 2 of my function. So, sorry about that. So I'm going from 0 to 2. Well, guess what? This area above here is exactly the same area as this down here. So this really turns out to be 0. So I have the limit as x approaches 2, 0 over 0. Oh, so when we were learning about limits and we ended up with 0 over 0, what rule did we use? Do you guys remember? What is the rule if you end up with, this is called an indiscriminate answer. So we learned a rule that was called L'Hopital's rule. And L'Hopital's rule says you can take the derivative of the top and the bottom and then reevaluate. Okay, so I'm going to take the derivative of the top. So this becomes g prime of x over, if I take the derivative of that, that just gives me 2x minus 2. And now I plug in 2. I just evaluate it there. So g prime of 2 over 2 times 2 is 4 minus 2. So that's going to be 2 on the bottom, right? Okay. So what is g prime of 2? And that, you just go to your graph. Here is 2. The derivative of it would be right here. So that's negative 4. All right. So how are the points distributed from this problem? Problem number 1, where's a concave? Negative 4 to negative 2 and 2 to 6. That was only worth 1 point. And it is. It's, those are the easy ones, being able to figure out concavity and where it's increasing and decreasing. Part B, we had to find out so the first thing we have to do is take the derivative. So here's the derivative. You got a point for just taking the derivative. Then you got a point for plugging to figure out what g of 3 is equal to. You got 1 point just for doing that. And then your answer, you got another point. So you get points for everything that you do. So what you want to do is you always want to try as many things as you possibly can, because that is how you get points on an AP test. Now, you might only be able to get part A. You might only be able to get the derivative of part B, but you want to do as much as you can. And then part C, finding the integral. So you got a point for plugging in the 2 and figuring out that you have to use L'Hopital's rule. And L'Hopital's rule says, so that gave you 1 point just to figure that out. And then I got another point for taking the derivative of that, plugging it in and getting a value out. So that is how the AP test is set up. Now, I will tell you, every year there is a problem like this. That is why I put that assessment in last week. I think it was the D assessment. You have to know how to do these problems. They're always there. This was last year's problem. It was there. It will be there this year. I guarantee it. Okay. Now, the new material for this week, we're going to be talking about area between curves, and we're also going to review limits. Let's use geometry to figure this problem out, okay? This problem, it says use geometry to find the area between the two equations, y is equal to 3 and y is equal to 6, from x equals 2 to x equals 6. Okay, so I'm just going to use geometry. So how would I do that? I would, y is equal to 3. So I just draw that in right there. Y is equal to 3 is a horizontal line. And y is equal to 6. It's another horizontal line. And I want to go from 2 to 6. What is the area of that? What is this area between these two curves? What is my area? 12, okay? Fairly easy to find, right? Now, if I wanted to use calculus, I would do this. Calculus says that I'm going to go from the starting point to the ending point on the x-axis. So I'm going from 2 to 6. And then top function minus the bottom function. Well, the top function is 6, and the bottom function is 3. Now, most of the times they're not going to be that easy. They're gonna end up being like x squared minus 4x, something like that. They're not going to be like this. But I'm just trying to show you that this does work. So 6 minus 3 is 3. So this is the integral from 2 to 6 of 3. If I take the integral of this, I get 3x from 2 to 6. I plug in the 6. 3 times 6 is 18. Minus, plug in the 2. 3 times 2 is 6. That gives me 12. So I just solved that problem using calculus. When you're trying to find the area between two curves, it is the top function minus the bottom function. That is it. That is the notes for today. So, area between two curves. The area between two curves, y is equal to f of x, y is equal to g of x, from a to b is the integral of f minus g from a to b. And now, f is the top function, g is the bottom function. So here's an example, or this is how they do it. So if this is f of x right here, and this is g of x right here, and if I'm going from a to b, but because what it's doing is it's just trying to find all these area between these two things. So it's a super simple formula to use. So in this problem here, this is an AP question. There is always an area, volume, and we haven't talked about volume yet. We start that next week. But there's a volume. We'll be finding volume next week. There's always a problem like this on the AP test also. I've been doing this for a long time. I know what's going to be on there. So in this problem, It says, let R be the region in the first quadrant bounded by the graph of y is equal to 2 the square root of x, the horizontal line y is equal to 6, and the y-axis is shown in the figure above. Find the area of R. And then part B would be find, so next week we're going to rotate this about the x-axis and it's going to form a volume. That would be the next question. Find the volume of this if I rotated it around the x-axis or if I rotated it around the y-axis. Doesn't matter. But this week we're just dealing with area. So I'm looking at this. This is the top function. Oops, let's put this in red. This is the top function. This is the bottom function. Top minus bottom. So the top function, they said, was y is equal to 6. So this is the integral from 0 to 9. Top function is 6. Bottom function is 2 the square root of x. Solve. I am going to let you guys figure out the area between the two curves there, or between those two curves, okay? So that means, and I don't want you to use your calculator this time. I want you to work this out by hand, because a lot of times this problem is done by hand. Okay, now, could you use your calculator? Absolutely. Your calculators know how to find the integrals. You could just put in 6 minus 2 to the square root of x. That's a great way, and I would say that every problem that you do from now until the end of the semester, use your calculator to check your answers. I'm not saying to do all your problems by hand. Well, I am. I'm saying do your problems by hand, but then check your answers with the calculator. Okay? So, what is my answer here? What is the area between those two curves? Okay, either if you have an answer, make sure you check it with your calculator too, just to make sure you practicing putting into your calculator. Now I'm going to start working this out down at the bottom. So 36, awesome. I don't know what the answer is because I didn't do the problem yet. But if I, when I look at it, you didn't check it yet? Okay, make sure you check it so you're really practicing on your calculator. So if I do this problem, I'm going to go 0 to 9, and then I'm going to go 6 minus 2x to the 1/2. Okay, so I'm, if I'm going to take an integral, I need a power here. All right, so if I take the integral here, this becomes 6x minus, and then 2x to the 1/2 means I have to add 1. So if I add 1 here, I get 3/2. So that would be over 3/2, or multiply by 2/3. That would be the same thing. So I have 4x to the 3/2 over 3 on the interval from 0 to 9. Okay. Now, this is where, most of the times they give you numbers that you obviously can put in there. Okay, so if I put 9 in here first, that's going to be 54 minus, now if I put 9 in here, well, the square root of 9 is 3. 3 to the 3rd power is 27. Oh, I don't even have to do that because I have 4 times, and then 9 to the 3/2, that's 27, right? But that's over 3. So that gives me 9, so that's 36. Okay. So I have 54 minus 36 when I plug the 9 in there. So 54 minus 36 is equal to, oops, my calculator's not on. 54 minus 36, which is equal to 18. But then I have to also put the 0 in there. Well, that's going to be 0. That's going to be 0. So my answer is 18. Boom. So your calculator was correct. Now, Isabel, take a look at my work. Okay. Did you get the integral correct? Did you get 6x minus 4 times x to the 3/2 over 3? Esther, how about yourself? Did you get the right answer there? And this is where, and that's why these types of problems, some of them you are going to need to use a calculator on, but a lot of the area ones you don't need to. But you should be checking you should be checking yourself on your calculator. Your calculator doesn't lie. I mean, when I saw the answer 18, that made a little bit more sense to me than the 36, but I mean, I didn't know for sure. So I wanted to make sure I worked it out, but you really need to be able to figure out, if you put 9 in here, 9 to the 3 halves, you guys know how to take a number to a fractional exponent, correct? Because a lot of the things, they're testing your math knowledge. I mean, here, yeah, I take the integral and I get this. There's no more calculus in this problem. It just becomes an arithmetic problem. Do I know how to plug 9 in here? 6 times 9 is 54 minus, 9 to the 3 halves. Well, that's 27 times 4 over 3. Well, that's 36. Those are things that you need to know. Okay? Are we good on this problem? Top function minus bottom function is how we find area. All right. And this was an AP question from, I'm not sure what year it was, but it is a problem. And here's the answer, or it worked out a little bit nicer than my work. Okay. So here's another problem. It says, now this one you cannot do without a calculator. This is a calculator-based problem. You could not do this problem without. So I am telling you, you need to use your calculator on this one. Okay? So in this problem, it says, in the figure below or above, I kind of cut and pasted, so it's to the side. R is the shaded region in the first quadrant bounded by the graph y is equal to 4 natural log of 3 minus x. The horizontal line y is equal to 6 and the vertical line x equals 2. Find the area of R. Okay, so I'm going to let you guys set this problem up, plug it into your calculator, see what you get for an answer. All right. And I will wait a little bit and then we'll go through the problem. All right. 6.816. Okay. Now, if I just had to wild guess it, okay, this, if the whole rectangle is 6 by 2, right? So that rectangle, if it was the whole thing, it would be like 12. And since more than, or about half of it, a little bit less than half, is gone, 6.81 sounds about right. So now if I'm going to do this problem, I've got the integral, and then I'm going from 0 to 2, right? 0 to 2. Top function is 6 minus the bottom function. Okay. Now I'm going to plug it into my calculator because I cannot do this without a calculator. So math down to fint And what is it? 6 minus 4 natural log of 3 minus x. And then comma x, comma, where did I start? 0, comma 2. Hit enter, and I get 6.81665. So that is correct. Okay, very good. So setting the problems up should be fairly easy. It's just top function minus bottom function. All right. Oh, and there's the answer. All right. I'm going to let you guys work on this by yourselves. It said set up the definite integral that gives the area of the region bounded by the graph of y1 x squared plus 2x plus 1 and y2 2x plus 5. And all you have to do is set it up. So what answer is correct there? A, B, C, D, or E? All right, so you're just setting it up. Don't even have to solve it. You just have to know. And this is a great way for the AP test to see if you understand how to find area between curves. Just set the problem up. You don't even have to work it out. Okay, so which one of those is correct? Letter C. Do we agree? All right. So if I was going to do this problem, I've got top function. So this is my top function here. So that is, so my integral is from 2x plus 5 minus, and then I would put this inside parentheses because if you don't, you're going to really mess this up. So this is x squared plus 2x plus 1. I don't see that here. And it goes from -2 to 2, so that's easy enough to do. But now this is I'm gonna rewrite it as 2x plus 5 minus x squared minus 2x minus 1, because that minus sign goes to everything. So negative x squared, 2 x's are gonna cross off, plus 4. Negative x squared plus 4. So letter C is correct. Very good. Excellent. Okay, so decent problem to see if a student knows how to set the problem up. All right, this one is yours. It says the area of the region bounded by the curve. Now this is a non-calculator part. It says it right here, no calculator. I want to see what your answer is. Now obviously, when you plug in numbers, you don't have to do e to the 4th. You can just leave it as e to the 4th. So work this out, see what you get for an answer. Okay, it's a pretty good one. It really makes you, you have to understand how to take an integral of e to the 2x. So I'm going to let you guys work on that and see what you get. All right. Any answers? A, B, C, D, or E? You're stuck? Awesome. Not awesome, but now, this is a non-calculator problem. So the first thing I did is I thought about this, when I thought about this problem is, I thought, okay, I can't use my calculator, so I can't graph it out. So answer C, I'm not 100% sure what the answer is. I think it is C. So e to the 2x, in my mind, that's an exponential function. And it should look something like this. It says the area of the region bounded by the curve e to the 2x, the x-axis, the y-axis, and the line x equals 2. So x equals 2 looks like this here. It's a vertical line. So my integral is going to be from 0 to 2. Top function is e to 2x minus the bottom function. Well, that's just 0 because it's the x-axis. So I don't have to put anything in there, and that's just 0. Okay, so this is my whole problem right here. The integral from 0 to 2 of e to the 2x. Well, how do I take an integral of e to the 2x? That is e to the 2x over 2. Because we always have to divide by the derivative of this. And that is on the integral from 0 to 2. So if I put 2 in here, that's going to be e to the 4 over 2 minus, and then I'm going to put 0 in here. Well, if I put 0 in here, e to the 0, anything to the 0 power is 1. So the top is going to be 1, the bottom is still 2. So that would be my answer right there. Now, do you see how the AP exam, what are they checking on this problem? Well, they're checking to see if you know how to find the area between two curves. They're also checking to see if you know how to take the integral of e to the 2x. Those are some things that, when you take the test, it's not like so many of your math classes previous, it's just one type of problem and you just do that. Well, when you get to these types of problems, I mean, they put a lot of things together. You have to be able to look at a problem and say, oh, okay, I've got to take an integral of e to the 2x. Well, if you don't know that that's e to the 2x over 2, there's no way to get this answer right. All right. Well, I suppose there is. You could guess at the answer. Does happen. All right. I think we already went through this problem, didn't we? Yep. Now, you could also find the area, because if you take a look at these two graphs here, these graphs, you can't find the area between the two curves because the curves are going up and down. So these have to be done a little bit different. The first ones that we just did, it was top minus bottom, right? Well, if you're integrating along the y-axis, so we're going this way, this is going to be, this is going to be your a and your b value. How low do you go? How high do you go? So it's going to be the integral from a to b, but it's going to be right minus left. The right function minus the left function. So it's very similar, okay, except now our integral is going to go from the, how low is the area to how high it is. That's your a and your b value on your integral. And then you're going to go right function minus left function. That's it. That's the only difference. So let's try an example. So in this problem here, it says determine the area of the region bounded by x equals 3 plus y squared and x equals 2 minus y squared. And you're going from 1 to negative 2. So I think I have the work over here. Okay, so all you do is you just plug it in. Okay, so if I'm doing this problem, I'm just going to go, well, and I'm not going to work this one out. The integral from, what do we say, negative 2 to positive 1. The right function is 3 plus y squared minus the left function. I'm going to put this inside parentheses, so 3 plus y squared. Oh no, sorry about that. It's 2 minus, yikes, 2 minus y squared. And that would be your integral, setting it up. So it's very similar. Now, some kids would say, okay, so if I had negative 2 to 1, so this would be 3 plus y squared minus 2 plus y squared, right? Because that minus goes to both of them. So this would end up being negative 2 to 1. And then what is that? 2y squared plus 1. Now, when you take the integral, it doesn't matter if it's a y there or an x or whatever. You just take it normally. So you just take the integral. So this would be 2y to the third over 3 plus 1y, and that would be on the integral from -2 to 1. And then you would just plug your number in. Okay, I suppose we can finish this one. So if I plug my number in there, what is that? 2/3 plus 1. 2/3 plus 1 minus, and then I put -2 in here. So that's going to be -8. -8 times 2 is -16 over 3. So -16 over 3 plus -2. And if you work this out, you should get the area in between those two curves. So 90% of all the problems you're going to see are going to be top minus bottom. You might run into one or two questions right minus left, okay? But they're solved exactly the same way. Okay, so you can just plug it in, get your answers. All right. So the rest of today is just reviewing limits. Okay. If I gave you, I want to go to a separate sheet of paper. Okay. So if I gave you a problem, let's say I gave you this problem, the limit as x approaches 3 of 4x plus 5. What would you say the limit is for that problem? $17, right. The first thing that we learned in first semester was when we're finding a limit, we just plug it in. A limit is the intended height the function is supposed to go to. Now, what if I gave you the limit? Now I got to make up these problems as I go. All right, so 1 second here. Okay, so what if I gave you a problem like this? The limit as x approaches 2 of x squared minus 4 over x plus 2. Now, let's go x minus 2. Sorry about that. X minus 2. Okay, what do you get when you plug 2 in there? Zero over 0. So there's two ways we can solve this. We could factor. So I'm going to factor the top, x minus 2, x plus 2, over x minus 2. Well, the x minus 2's cross off. So now if I plug 2 in here, I end up with 4. Now the other way that we learned is that if we ever end up with a 0 over 0, we can use what's called L'Hopital's rule. We could take the derivative of top over the derivative of the bottom. Well, the derivative of the top is 2x. The derivative of the bottom is just 1. And then plug your 2 in. 2 times 2 is 4. Oh, I get the same answer. So sometimes you can factor the top and bottom, but a lot of students, they would just rather use L'Hopital's rule, which just says you take the derivative of the top, you take the derivative of the bottom, you end up with, and then you plug in the value, okay? So is that bringing back some memories? Okay. Then we went, once we did this, we went to what we called the limits as it went to infinity. So we had problems like this. I gave you, get this a little thinner here. I gave you something like 3x to the 4th plus 5x squared minus 4 over 5x to the 4th minus 3x plus 10. And I said, what is the limit as x approaches infinity? Okay? What is the limit as x approaches infinity of 3x to the 4th plus 5x squared minus 4 over 5x to the 4th minus 3x plus 10? 3/5 is correct. Okay, and the reason it's correct is because if the power on top and bottom are exactly the same, the highest power on top and bottom are exactly the same, then all we do is we just take the numbers in front, 3/5. Now, what happens if the powers aren't the same? Let's say that I have the exact same problem, but this is to the 7th power. I have 3x to the 7th plus 5x squared minus 4 over 5x to the 4th minus 3x plus 10. Then what is the limit as x approaches infinity? Three? I disagree with that. And it is 0 or does not exist. I disagree with that. Big over small equals infinity. Small over big equals 0. So you just have to look at the powers. Highest power on top here is bigger than this one. This function's limit is going to be infinity. Now, if I gave you something like, let's say I gave you 3x to the 4th plus 5x squared minus 4 over, let's say 3x to the, let's go 8th plus 5x squared minus 4. Now, I have a small over a big. Guess what? That's 0. Why? Well, think about it. If you had 1 over a very, very big number, what does that equal? It equals basically 0. So these are the things that you have to remember. Big over small, infinity. Small over big, 0. And if they're exactly the same, you just take the numbers out in front. Okay? Yes or no? Can I go on to some practice problems? Okay. All right, so now let's try some problems that you would see on an AP test dealing with limits. Okay, so just got to find where they are. All right, so here we go. Part A. I think that was my first slide. Yep. Okay. So what is the limit? Is 5x to the 3rd plus 27 over 20x squared plus 10x plus 9 as x approaches negative infinity? Letter E. I'm going to go with letter A. And the reason, now, I can see why you said E. Okay. It's negative, right? So we're going to a very negative number over a very small. So this is really big over small, but it's really big negatively because it's a negative x. So I'm going to go with A there. Okay. Okay, so I'm going to go with A. How about number 2? The limit is x approaches infinity of 3x squared plus 27 over x to the 3rd minus 27. Limit is going to be, or the answer is going to be 0 or letter E. Agreed. How about the third one? The limit is x approaches negative infinity of 4 minus x squared over 4x squared minus x minus 2. Negative 1/4 is correct. Highest power on top, highest power on bottom, both exactly the same. So we just take the number on top, number on bottom, negative 1/4. Good. I thought we'd catch you. I thought somebody would say positive 1/4, but I guess that's not one of the answers down there. So negative 1/4 is correct. Good. All right. Now, how about no, it's the same problem. No, I guess it's not. The limit as x approaches positive infinity of 4 minus x squared over x squared minus 1. What is my answer? Negative 1 or letter D. Correct. Second problem, it says, what is the limit as x approaches 3 of x minus 3 over x squared minus 2x minus 3? Okay, what is my answer? 0? That was pretty quick. I don't, let me check. I don't think it's 0. I could be wrong. But in this problem, approaches 3. Yep, yes, it approaches 3. Yes, this one, it's going to approach 3. So in this one, if I put the 3 back in, guess what happens? I end up with 0 over 0. Now, I'm not a big fan of factoring, so I'm just going to use L'Hopital's formula. I'm going to take the derivative of the top, which gives me 1. I'm going to take the derivative of the bottom, which gives me 2x minus 2. Then I'm going to plug in 3. So 2 times 3 is 6 minus 2, so 1/4 is the correct answer. Yep. Okay. And then I think this is the last slide for today. Just a couple more problems. What is the limit as x approaches 2 of x squared minus 4 over x squared plus 4? Now this is, I don't know. Letter B, 0. I agree with that. Okay. So in this problem would trick some kids, because if you put 2 in here, you end up with 0 on top. And if you put 2 on the bottom, you end up with 8. Well, 0 over 8 is a number. That is 0. And some kids, they would start doing L'Hopital's rule. L'Hopital's rule you can only use when it's 0 over 0. Okay. If it's 0 over 8, that is 0. I mean, that answer is 0. So that's an interesting one. Some kids, they want to do L'Hopital's rule right off the bat, no matter what. It's like, you can't do that. That's not. You can't use L'Hopital's rule when it doesn't fit the problem. Okay. And then the last problem, it says, what is the limit as x approaches infinity of 5x to the third plus 27 over 20x squared plus 10x plus 9? What is my answer? Letter A, which is infinity. I agree 100%. Okay, so today we reviewed derivative graphs. Okay, I'm not 100% sure, Isabel, if you have the grasp of those. So I think I'll probably start off each week with one, because I know it's going to be on the AP test. Okay, I just know it. So we'll start off with one of those each week, just to review derivative graphs. And then each week we'll review a little bit more. Like next week, we're going to review derivatives. Okay, we're trying to get ourselves, and obviously, hopefully, reviewing limits, all of a sudden it's like, oh, I do remember limits. So hopefully that helps. And next week we're going to go into, I believe, I'm not 100% sure, but I believe we go into finding the volumes of solids. So that will be next week. And then we'll do some review of derivatives, and we'll also do review of integral graphs again. All right. You guys have any questions before we go? All right. You guys have a great week. Hopefully we'll see you back next week. Bye. Oh, one question before you leave. Oh, they left already. All right, that's fine. The only thing I had is I had a question about not next Monday, but the following Monday after Easter. We don't have school on Monday, okay? So would Tuesday be okay to do our session Tuesday at 2 o'clock? Would that be fine? And I'll ask Isabel next week. I totally forgot to ask this week. But that was my plan, is to do our session on the Tuesday. Oh, you have work on Tuesday. How about Wednesday? Would Wednesday work? We'll talk about it next week. Just remind me, and then we can talk about to see what day would work. Okay. All right. Sounds good. All right. Have a great week. Bye.